Hi, welcome to Lesson 3. This lesson provides a brief overview of Kubernetes. The lesson starts with a video about cloud-native computing, because that is what Kubernetes is all about. Next, you'll learn how Kubernetes enables cloud-native computing. You'll learn about its core functions and where it comes from. After that, I'll explain how Kubernetes is truly open source, which is guaranteed by the Cloud-Native Computing Foundation. And after that, I'll explore Kubernetes architecture and essential API resources. You'll also find a lab to practice your skills. So the essence of Kubernetes is cloud-native computing. But what exactly is it? Well, it's all about providing access to applications on the internet. In order to do so, the application should be hosted in the cloud. And when it is hosted in the cloud, the application is decoupled from specific servers. You don't want your application to have any relation to a server because then it's bound to a physical location, and that's no good. So if an application is disconnected from any specific server, facilities must be provided to take care of specific features. Think about facilities that are normally taken care of by the individual server, like access to configuration. Normally, you would have a configuration file somewhere on your server, but how are you going to organize that if you're in cloud? Likewise for persistent storage. If your application is not on a server, then where is it going to store its data? Or application access. You can't address the server where it's running. You need some way to access the application in the cloud. Cloud-native computing is the answer to take care of all problems like these. Let me make a drawing for you to show you what exactly is involved. Okay, so what is the challenge of cloud? Well, if this is your cloud, then your cloud is using some servers, right? But the essence when you are running your application in the cloud is that your application should not have a direct relation with any of the servers. So if you have an application that is running on a local computer, it's pretty simple. You fetch everything from the local computer. But here you need to make sure that your cloud has a solution for configuration, has a solution for storage, and has a solution for access for your application that can run on any of these servers. And that's exactly what Kubernetes is going to do with Kubernetes resources. These resources replace the files that you would normally have on your own servers. And that's why we need all of these resources. So now that you know about cloud-native computing, let's talk about the relation of Kubernetes to cloud-native computing. Kubernetes is the open source platform that allows containers to be used in a cloud-native environment. And when I say the open source platform, that means that it's the de facto standard and there isn't really anything else in open source. To do so, Kubernetes orchestrates containers. That means that it ensures that containers are running where they need to be running and as many instances as you need, which is provided by the scalability. Scalability is ensuring that a sufficient amount of containers are running to deal with the current workload. To realize all of that, the Kubernetes API defines a set of resource types, such as pods, deployments, and config maps that allow for storing information in a cloud-native environment where no relation to specific servers exists. Let me make a quick drawing to show you what this is about. So what is this orchestration? Well, we still are talking about cloud with the different servers that are used behind your cloud. And in your cloud, you have your Kubernetes application. And this application is monitored by Kubernetes. And Kubernetes makes sure that it runs somewhere. And suddenly, if a lot of requests are coming into your application, well, Kubernetes can orchestrate the availability of your application to make sure that it runs on multiple nodes as multiple instances. And if something bad is happening, like one of your servers is going away, well, Kubernetes orchestration makes sure that the application will run somewhere else. So because of Kubernetes orchestration, you don't have to worry about the number of instances or where exactly your instances are running anymore. So where does Kubernetes come from and why has it become rapidly so successful? That's maybe because Google Borg is at the origins of Kubernetes. And Borg is the platform that Google had been using since the early 2000s to offer Google applications in a cloud-based environment. Based on Google Borg, Google open sourced a platform-agnostic solution for orchestrating containers. And Kubernetes was first announced in June of 2014, and the source code was donated to Cloud Native Computing Foundation in 2015. And I guess that it's the reliability and the reputation of Google as a company that made that Kubernetes has become a success so rapidly. Let's face it, Borg was using Google applications and donating that to open source. That means that the open source community has something that is ready to use. All right, what is the relation between Kubernetes and cloud native computing? Well, to understand, we need to know about Cloud Native Computing Foundation, which is a part of Linux Foundation. And Linux Foundation has a lot of experience hosting open source software and fostering the growth of open source software. Core mission of CNCF is to provide open source standards for cloud native computing. And it hosts different projects that are doing so. And of these, Kubernetes is a key project. It provides a platform for running cloud-native applications. Now, CNCF provides an open environment where different projects can provide solutions for cloud-native computing. It's a healthy ecosystem, and as such, the result is that different projects exist that propose a solution for the same problem. So sometimes there are multiple alternatives and you need to choose. And that's what's going on where you are running Kubernetes. Users need to choose which projects or solutions to use on top of Kubernetes to provide specific functionality. And that can be done by selecting individual projects and integrating them with vanilla Kubernetes. Vanilla Kubernetes is how we call the core of the Kubernetes system, without any of these projects integrated. You can also use an alternative, and that is the Kubernetes distribution. In Kubernetes distributions, different projects can be integrated. Now, before continuing, let's have a look at the CNCF website and check on the projects that they are hosting. So the CNCF website is at cncf.io, and they like showing you advertisements about KubeConf, which is their main Kubernetes conference. But what I want to show you here is the projects. On the left side, you can see the status of the projects. They are graduated or incubating or sandbox. Where graduated means that they are fully mature, incubated means that they are being introduced, sandbox is for new projects, and archived is for old projects. Now click on projects and select whichever you want for an overview of the different projects that exist. And just to pick out a couple of them, etcd is the core Kubernetes database that is integrated. Core DNS is taking care of DNS in Kubernetes. Helm is a package manager, and there are more projects. Now, it doesn't have to be graduated, incubated, it's pretty mature as well. Like CNCI, which is the network interface that Kubernetes is using. And you can see multiple projects being offered here. So all of these projects together compose a Kubernetes distribution. So in a Kubernetes distribution, the different CNCF projects can be integrated in a working Kubernetes environment. Some distributions are, as we call it, opinionated. And that means that just one CNCF project is integrated to provide a specific solution. That means that you don't have to choose this project is just what you have to use. Some distributions are more open and leave a choice to its users about the specific solution that they are using. And the distribution may also provide support, which makes it possible to run Kubernetes in environments where reliability is important. From that support perspective, it's also important to understand why distributions are sometimes opinionated. If they just have one integrated project, they can offer better support on it, because the support engineers can fully focus on that one project. Now, there are different distribution types. There is cloud-managed distributions, which integrate in public cloud offerings, and they include EKS, which is Elastic Kubernetes Services offered by Amazon, or AKS, which is Azure Kubernetes Services offered by Microsoft, or the Google Kubernetes Engine, which is offered by Google. These are convenient if you want to run Kubernetes in public cloud, but not everybody wants to do it, and that is why there is also on-premise distributions, which focus on installation in a company's data center or private cloud. And some on-premise distributions include Google Anthos, or Rancher, or Red Hat OpenShift, or Canonical Kubernetes. There are also some minimized Kubernetes distributions, which are provided for testing and learning. And these include Minikube. Minikube is what we are going to use in this course, and you will find that it's a full Kubernetes distribution. There is K3s, and there is OpenShift Local, or CRC, which is a minimized OpenShift learning environment. Now, the scope of a distribution is not always limited to a specific environment. That means that some distributions can be used in cloud and on-premise as well, like Red Hat OpenShift, for instance. In this course, we are going to use Minikube. Minikube comes from a Kubernetes special interest group, and it's a nice learning environment that behaves as a real Kubernetes distribution. Before we start to talk about Kubernetes itself and using it, let's talk about Kubernetes architecture. In the architecture, it all starts with the control plane, which is one or more nodes where the Kubernetes core services are running. In an ideal situation, you will have multiple nodes to provide some redundancy in case one of the nodes goes down. Now, these services are Kube API Server. That is the part of Kubernetes that provides access to the API. That's the component that you talk to when you are interfacing Kubernetes with the kubectl utility. There is the etcd, which is the Kubernetes database. That is where all Kubernetes resources are stored. There is the kube scheduler, which is responsible for scheduling pods at a specific location. And there is the kube controller manager, which manages core Kubernetes processes. Apart from the control plane, there are the worker nodes. And the worker nodes run the containerized applications by using two core services. These are the container runtime, which is the part that actually runs the container. And there is the kubelet, which is the part that is contacted by the kube scheduler to run the actual containers in pods. And in case you are wondering, don't we need Docker or Podman on the managed nodes? No, you don't, because remember, Docker and Podman are container managers that make sense in a standalone environment. In a cloud or data center environment, Kubernetes is going to be the container manager, and that's why you don't need Docker or Podman. Let me make a drawing for you to show you how this all connects together. All right, let me explain Kubernetes architecture. Core component of the Kubernetes architecture is what we call the control plane. It can be one server, can also be multiple servers, depending on whether or not you want to set up high availability, which is very common in production environments. Then we have the Kubernetes worker nodes. These are the nodes that are going to run user applications. Now, what are the Kubernetes core components that are making sure that you can run your applications? Well, to start with, every single node needs to run containers. The CRI is a container runtime interface, which is taking care of that. And on top of that, every single node is running the kubelet. The kubelet is the Kubernetes part that makes sure that Kubernetes pods are going to be scheduled to run somewhere. And then we have the Kubernetes core components. Core component number one is the API server. The API server is what you are going to use as a user. When you are using the kubectl command, well, the kubectl command is talking to the API server. And when you create resources, these resources are added to the etcd. The etcd is the central Kubernetes database. And from there, the scheduler is going to pick up your resources and will find eligible nodes. And that means that in the end, the pod that you are creating is going to be scheduled to run on either of these worker nodes or maybe on both, depending on what exactly you want. So an essential component of Kubernetes is the API resources. The API resources allow you to define how your application is working. So they're all about storing and running applications in a Kubernetes environment. As we have seen before, the challenge in a cloud-native environment is that you don't have a relation to specific servers. And that means that you cannot just put a file somewhere. You need to do this in a smart way. And that is where the API resources come in. You'll learn about a lot of API resources throughout this course. But I want to start with some of the most essential API resources. This is your key terminology, and I advise you master these resource types as fast as you can. So what are these essential resources? Well, it all starts with the pod. The pod is the minimal entity that is managed by Kubernetes. And pods run one or more containers. So Kubernetes is not starting a container. Kubernetes is starting a pod. It doesn't know about containers. And one important feature of the pod, for instance, is the IP address. Containers don't have an IP address. Next there is the deployment, which is the preferred way for running applications, because deployments add replication and zero downtime application updates to the pods. We have the config map, which is used to store configuration files and startup parameters. There are services which load balance incoming traffic to application instances. And there is ingress, which nowadays is being replaced by Gateway API, which provides a reverse proxy for application access. And the final resource I want to mention here is the persistent volumes, which represent persistent non-ephemeral storage. Let me make a drawing so that I can show you how all these resources work together to provide an application in Kubernetes. Alright, so how are these Kubernetes resources used? Well, it's all about a container, but Kubernetes doesn't manage containers. Kubernetes is putting the containers in a pod. And the pod as such is the smallest entity that Kubernetes can run. But Kubernetes might want to run multiple instances of your pod, the so-called replicas. And in order to manage these replicas, well, in the past we had a replica set. Nowadays, the replica set is automatically created if you run the container as a deployment. The deployment is really the resource that you are going to use to run a scalable application. But that is not all, because you want to be able to access your application and to store configuration. And there's a couple of resources related to that, like the config map. The config map is a Kubernetes equivalent for your configuration file. And closely related to the config map, there is the secret, which is a base64 encoded configuration. You can also work with persistent volumes, the PVs. And these persistent volumes allow you to store files externally. But that's not all. You also want to be able to access your application. And that's where the service is coming in. The service is a Kubernetes resource that functions as a load balancer, because if you are running multiple instances of your containerized application, you need something or someone to load balance the incoming requests. Now, in order to make accessing these services easier, Kubernetes also is using ingress. And ingress is a reversed HTTP proxy that communicates to the service and makes sure that users can access your application. And that's just the essential resources. Kubernetes has lots of resources to store whatever needs to be stored in the cloud. Now that we are at the end of this lesson, let's do a lab. Now there's one thing that you need to realize. This lab works well if you installed an Ubuntu virtual machine and you cloned the Git repository and you have run the Minikube script in the previous lesson. If you want to use Kubernetes in a different environment, then I would recommend you first study lesson 4 and then you come back to do this lab. Now in the lab environment, use Minikube start to start Minikube. Then you type kubectl API resources to show a list of all API resources that are provided. And on any resource name that is shown, use kubectl explain on the resource name, like kubectl explain pod. That will give you more information about this resource. Next, from a browser, go to kubernetes.io/docs to get access to the Kubernetes documentation. And from this documentation, type pod in the search bar to get access to more information about pods. Important tip, on the exam, you will have access to the documentation on kubernetes.io/docs. And as you will notice, that will really come in handy. Okay, so this continues on the Ubuntu virtual machine that we have set up before. And I'm going to use Minikube start, which should be doable at this moment. And that is going to run Minikube. So now that we have Kubernetes up and running in Minikube, we can use kubectl API resources to show a list of all the different API resources that are available. This list does not fit on screen, so I recommend running it again. Pipe the output through the Linux LESS utility, and there you can see resources like the pods and the services and the deployments and many more. We will talk about quite a few, not all of them, in the remainder of this course. Now, if ever you want to figure out what is going on in a resource, you can use kubectl explain on a resource. kubectl explain on pod, for instance, is showing the different fields in the resource specification, of which the most important is spec. So if I make that kubectl explain pod.spec, then we can see all the different parameters that you can have in the pod specification. We'll discover more about them in the next couple of lessons. Now, if ever you want to create your own resources, you need the Kubernetes documentation. So that would be kubernetes.io/docs. And there you can look for any resource that you want to learn more about. Pods, for instance, and that is showing a list of all the different resources about pods. So you click the appropriate resource and you can find the description and even the YAML code that is happening behind your pods. That's something that we will discuss in lesson 5, but for now I wanted to show you the documentation, and the good news is that the documentation is available on the exam and you can use it on the exam. So this is definitely something to consider, and everywhere where it is relevant and helpful, I'll show you the documentation and I'll tell you why this part of documentation can be used on the exam.